All right, let's talk about a choice that is absolutely critical for anyone getting serious about AI on their own machine. We are pitting the next-gen monster, the RTX 5090, against the tried and true veteran, the RTX 3080. This is going to be fun. So you're looking to power your AI ambitions, right? Whether you're doing creative stuff, research, or just developing cool projects, you've probably hit that wall and asked, how much GPU do I actually need? Your graphics card is the engine, plain and simple. It's what's going to either let your ideas fly or keep them stuck on the ground. So in one corner, you've got the NVIDIA RTX 3080. I mean, for years, this has been the go-to card for so many people. And in the other corner, we have the RTX 5090, which is basically a peek into the future of what we can do with AI at home. This isn't just a small step up, it's a massive generational leap. Okay, let's set the stage real quick. These are consumer cards, but they're incredibly powerful. We're talking about things like running Stable Diffusion to create images or fine-tuning some smaller, specialized AI models. What we are not talking about is training something like GPT from scratch. Come on, that's a whole different universe of hardware. So what actually makes these cards tick? What's under the hood? It really all boils down to the raw horsepower, the computational units that are doing all the heavy lifting for those AI calculations. Just look at this chart. This is the difference in CUDA cores. You can think of these cores as the individual workers in your GPU's little factory. The RTX 3080, it's got a pretty solid crew, about 8,800 workers. But the RTX 5090, it's not bringing a crew, it's bringing an entire army. We're talking over 21,000 of them. Yep, that's a real number. A staggering 2.5 times more raw processing units. This isn't just a little tune-up. It is a fundamental redesign of how much sheer power they can cram onto a single chip. But you know, a bigger workforce needs a bigger workshop, right? For a GPU, that workshop is its VRAM. The 3080 gives you a decent 10 to 12 gigs. The 5090 just obliterates that with 32 gigs of cutting-edge GDDR7 memory. And this is so important because more VRAM means you can load up bigger, way more complex AI models without having to cut corners. But here's the thing, performance isn't just about having more of everything. It's about the architecture, the actual intelligence of the chip. And that's where the real AI magic happens. See, at the heart of NVIDIA's AI power are these things called tensor cores. These are the specialists. They're built for one reason and one reason only, to just blitz through the kind of math that AI and deep learning are built on. They're the AI gurus in the factory. And right here, this is where that generation gap becomes a huge chasm. The 3080 uses 3rd-gen tensor cores, which are great, but the 5090 jumps 2, not 1, but 2, full generations to 5th-gen cores with the brand new Blackwell architecture. That means they aren't just faster, they're smarter, more efficient, and way more precise for the complex stuff modern AI demands. But all this power has to live somewhere in your computer, and man does it get hungry. This brings us down to earth, to the real-world stuff you have to think about when you're planning your PC build. The 12GB version of the RTX 3080 has a TDP, or thermal design power, of 350 watts. Now that's already a lot of juice. You need a good power supply and decent airflow in your case to handle that. And then there's the RTX 5090. Whoa, at a massive 575 watts, this thing is a completely different animal. This is not a component you just casually drop into your current rig. No, you have to build your entire power and cooling strategy around this one part. So let's just pull it all together for a second. When you look at this table, the story is crystal clear. On every single metric that matters for AI, from the architecture and CUDA cores to the memory and the generation of its tensor cores, the RTX 5090 is just a quantum leap ahead of the 3080. And hey, a quick, very practical warning, this kind of power takes up a lot of space. Your typical RTX 3080 is a 2, maybe a 3-slot card. The 5090, we're hearing it's going to be a chunky 3, maybe even a 4-slot design. So seriously, before you start dreaming, get out a tape measure and make sure it'll actually fit in your case. Okay, so after all that, which one of these powerful engines is actually the right choice to fuel your AI ambitions? Look, the RTX 3080 is still a fantastic, totally viable option, especially if you're a hobbyist or you're just dipping your toes in the water. It's awesome for entry-level deep learning, running popular stuff like Stable Diffusion, and just experimenting with neural nets without breaking the bank. But if you're a professional, a researcher, or a really serious developer, the RTX 5090 is playing a whole different sport. It's built for training medium-sized models, fine-tuning really complex stuff, handling insane real-time AI video feeds, and basically making sure your workstation is ready for whatever comes next. I mean, the verdict from the experts really couldn't be clearer. The 3080 is totally fine for hobby stuff. But for anyone doing serious AI work, the 5090 just operates on a completely different plane of existence. And what does that mean in the real world for you waiting for your models to finish training? Well, for a lot of deep learning tasks, you're going to see the RTX 5090 deliver somewhere around 2 to 3 times the speed. That is a game-changing productivity boost. We've based a lot of this on a really fantastic, super in-depth article over at bestgpusforAI.com. If you want to get even nerdier with the numbers, you should absolutely check it out. We've dropped the link down in the description. Just one final quick reminder, folks. As unbelievably powerful as these cards are, they are still consumer hardware. They are not enterprise-grade solutions designed to train massive large language models from the ground up. Let's keep our expectations realistic. You know, this comparison really shows the insane pace of progress. From the Ampere architecture in the 3080, through the Ada Lovelace generation in the 40 series, and now to Blackwell in the 5090. Every single step unlocks a whole new level of what's possible. So really, the question comes back to you. When you think about your projects, your goals, what you want to create, which one of these engines are you going to choose to build the future? Thanks for joining me for this breakdown.